Defining carbon-12 and carbon-14. Carbon-12 and carbon-14 are both isotopes of the element carbon, meaning they share the same number of protons, 6, but differ in the number of neutrons. These differences result in distinct properties, including their stability and how they are used in scientific applications, such as dating ancient materials. Carbon-12, stable and abundant isotope. Carbon-14, radioactive isotope for dating. Carbon-14, C14, is a radioactive isotope of carbon. It is formed in the upper atmosphere when cosmic rays interact with nitrogen atoms. Unlike C-12, C-14 is unstable and decays over time, making it useful for radiocarbon dating. Its atomic mass is 14 atomic mass units, and it decays into nitrogen-14 with a half-life of about 5,730 years. Stability. Carbon-12 versus carbon-14. The key difference between C12 and C14 is stability. Carbon-12 is stable and does not undergo radioactive decay, making it non-reactive and unaffected by time. In contrast, CARBON-14 is radioactive and decays over time, which is why it is used to estimate the age of organic materials by measuring the amount of C14 remaining. Use in radiocarbon dating. C14's special role. Carbon-14's radioactivity makes it invaluable for dating ancient biological materials. As living organisms absorb carbon, including C-14, during their lifetime, but stop when they die, scientists can measure the remaining C14 in a sample to estimate its age. This method is widely used in archaeology, paleontology, and geology. Abundance in nature. C-12 dominates. Carbon-12 is far more abundant than carbon-14. While nearly all carbon in the environment is carbon-12, carbon-14 makes up only about 1 part per trillion of the carbon on Earth. This vast difference in abundance is why carbon-12 is the primary form of carbon found in organic molecules, while carbon-14 is mainly used in scientific analysis. Decay rate. Different lifespans of C12 and C14. The decay rate of carbon-14 is an important factor in its use for dating. With a half-life of 5,730 years, the amount of carbon-14 decreases over time, allowing scientists to determine the age of an object based on the remaining C14. In contrast, carbon-12 remains constant, unaffected by time or environmental changes. Detection methods. Using C14 for analysis. To detect carbon-14, scientists use sophisticated instruments such as accelerators or liquid scintillation counters. These tools measure the amount of C14 left in a sample after it has decayed. The ratio of C14 to C12 allows researchers to determine how many years have passed since the organism's death. Environmental impact. C-12 versus C14 in nature. Both carbon-12 and carbon-14 are found naturally in the environment, but their roles are different. Carbon-12 is integral to all living organisms, forming the backbone of organic molecules, while carbon-14 is mainly used for scientific purposes, such as tracing carbon cycles or dating archaeological finds. Key difference. Stability versus radioactivity. The main difference between carbon-12 and carbon-14 lies in their stability. Carbon-12 is stable and abundant, forming the basis of life on Earth. In contrast, CARBON-14 is radioactive, decaying over time and serving a critical role in radiocarbon dating and the study of ancient life forms.